Hello everyone, welcome back. So in this video, we are going to understand the Leetcode problem number 2196. It's a create binary tree from the description. What is description? Is an array. So we have given a 2D array that is called descriptions, where descriptions at I is nothing but a combination of three things that is called triplet is parent I, children I, and is left. Means we have given values in the numeric where it is parent of who, these children. Okay, as you can see, I means for these children. Okay, means we have given first parent, then given its children, and then it is saying is it left side or right side in the binary tree. Okay, so it indicates the parent I is the parent of the given children in the binary tree of unique values. Like, okay, means we have given parent and child in unique values, so it is easy to build the binary tree, right? So when is left is 1, then the child is in the left side. If it is 0, means it is in the right side. Sorry, is left is equal to 1 means it will go to the left side. If 0, it will go to the right side, right, of the parent. You need to construct the binary tree, guys, from the given description, and you have to return the root. Okay, the test cases will be generated such that the binary tree is valid or not, right? That will check internally. So let's try to understand through the example so you will clearly understand. Okay, the very first thing that what we have given the description is 20, 15 and 1. So 20 is a node and 15 is a children in the left side. So see, we have 20 we have given, 15 in the left side, then we have get 20 and 17. So 20 in the right side because it's 0, right, and we have given. Then 50, 20 and 1 means 50 will be the node, right, root parent, and 20 will be in the left side and 1. So you need to connect this one. Then we have 50 in the right side like this, right, 50, 80. And then we have 80, 90 and 1 means 90 will go in the left side because it's 1. Like this you have to construct, right, and you have to return the root. So this is what we have to return like this. Basically the root node is the node with the value 50, right? As you can see, the very first node is 50, and since it has no parent, right, we will return that. Okay, and so we have the all the binary tree information. So the question is how you are going to solve this problem, right? It's you have given the array, right, and most important thing is you should understand what are the nodes we have given and how we will find the root, which one is the root node. The root node will be the root node that doesn't belongs to the children, right? Means it's not a children, right? A node which is not a children is called root node, like that we can say, right? So we need to filter that, and to filter that it's very important how to do that. So basically we will use a graph trick and then we will implement it. Okay, so let's go to understand how we will implement through the graph. So it has become very easy, guys, don't worry. Okay, so let me zoom out a little bit. Okay, now let's say the very first thing that you need to create the parent and child, right? Let's suppose this is a set, right? So set will create a parent, children and the parent. Okay, two sets we will create, and we will hold the all the nodes, right? And this node is a parent and this node will be the list of the children. Means each node we will keep, means the node that has the children, that information we want to keep in the map, right? So it become little easy to find the parent to the children relationship, right? So we are storing the parent to children relationship. Then we will build the parent to child and add the nodes to the assets. How will you do that? So over the description you have to go and you will get the parent, child and is left or not. So this information will get, and what we will do over the parent, we will add parent and child both, and in the children we will add only children. Why we will do that you will understand very soon, right? Because we want to filter the root. Let's understand further. Then we have to do the parent to child relationship, where what you need to do, parent to child relationship is a map. The very first you will just initialize it if it is not absent, if it is absent, right? Otherwise what you need to do is, once you have the data right, you need to add as a children and child and is parent, right? So we'll pass the parent, and parent will have the children is left as a relationship, will so store like this. Okay, so this list contains a array, right? Array form means it's a pair of what? The children and is left. Okay, so that we will hold as a each element. Okay, so this is a list, so we can add many as element we can add here, right? So that we will create a, we have created a for loop and will keep operating like this, means this parent can hold multiple childs also. Okay, the next important thing is why we have took, why we are adding the parent right here. In the parent we are adding parent and child. Let's understand here. Very first, that we will remove all the children from the parents, right? So that the leftover is a parent only, right? Means we want to filter that. After filtering, you need to create the tree node, right? So that is a root node, we can say, right? How? Just you need to do the parent iterator dot next, you will get the element, and that element will store over, we need to initialize for the root, right? So this parent, you know that the parent contains what? As an integer, right? In both we can say that, right? So we will get one node value, and this node will get initialized, and that become a root node. Okay, let's move ahead. Now the most important thing in the graph, right, what we need to do is the bfs is easy to create or construct the binary tree, right? Because we know the what is the starting point, and we can traverse left right like that. Okay, so we'll use the bfs to construct the binary tree, right? So let's suppose we will create a queue, and over the queue we will add the root node first. Then we'll go to the while loop, we'll check if it is not empty. Obviously we have just added the root node, so we'll get the parent from the queue. So once you get the queue, right, once you got the parent from the queue, you just need to iterate over the children of that parent. Means how we'll get that? From the parent to child relationship, we have added the parent and its children, remember here. So we used to add the parent, and we used to add the array of, you can say pair of the children and is left, right? So there can be multiple children can be stored here, right? So what we will do, that we'll create a for loop so that we can iterate over all the children and parents relationship. Okay, so very first thing, that you will pass parent to children, right? And from there we'll pass the parents value, right? Parents value, from the parents value if you pass, obviously you will get the children information. So there can be multiple childrens in the form of array, because it contains the child value and is left information, right? So once you got the child information, obviously you will extract that value. So you will extract the value, what is child value and is left, right? And you know that we have the child value and the is left here, so you can construct your child node also, right? Like this, from the child value. Now once you find the child value, you have to put first on the queue, so we can iterate over this queue, right? So you need to do, now we will put the information that is left is 1 or not. If it is 1, we'll say parent dot left, and we'll add this child node, right, after adding over the queue. Okay, otherwise we'll add on the right side. So it depends on the is left value where it will go, left or right, right? But the purpose, you have understood that the very first thing is that we will add over the queue, right? Then we'll extract from the queue, and then we'll get the its children information. If the children information be available, so we can extract that, and then we'll create the node, and then then we'll push again over the queue, and we'll check the relationship where it will go, and we'll add that. And this loop will continue until we will traverse for all the parent and child relationship. Okay, and obviously in this way we are constructing what? We are constructing, this is parent dot left, it will go right or left, like that we will building, right? So obviously the parent is nothing but the root node, and we have to return the root node, correct? Because we started from the root node. Okay, and we are constructing the next children node, it will go in the left or right, like that we will keep controlling for all the children and its nodes, right? And we'll find the finally the binary tree, and from the binary tree we'll return the root node. Okay guys, it's very important to understand that why we have used the thing that the children and parent, right? Because we want to we will add the parent and child, but we need to filter it, right? Once you filter it, you know that who is my parent node, right? So you know that this is our parent node, means the parent node means root node. This is our root node, and once you remove from the parent to all the children, the leftover is the parent only, means the root node only, right? And from the root node itself we can start from the queue, and over the queue we can iterate over all its children, and we can build the queue, we can add the relationship, and finally we'll build the construction of the binary tree. So that's all I have in this video guys. If you have any doubt, let me know in the comment section. I'll put this code in the comment section, you can get from there, right? And that's all I have in this. Thank you so much, and in case you have any doubt, you can ping me in the comment box, we can go from there. Thank you so much.